Hello, everybody. Welcome to our new TechCast. While we are waiting for the people to enter and listen this amazing presentation, I will remember that we are going to see a great session from Ziga Vaupot. Ziga, thank you so much for accepting presenting your session with us. He's going to talk about OCI Vision and Oracle Analytics, just like a box of chocolates, and who doesn't love chocolates, by the way? So this is how you're going to love this integration between OEC and OCI Vision. But before going to the topic, I want to share some things about our community. So first of all, if you are new to our TechCast, we usually have 2 TechCasts by month. We had Live from Oracle Cloud War during the, obviously, Oracle Cloud War in Las Vegas. And we're going to have an amazing panel about data mesh. So all the questions that you have about data mesh, if it's fit for everybody, we're going to have a great panel of experts. I'm going to host that session too. And it's going to have Stuart Bryson, Holger Friedrich, and Mark Rickman. So don't lose that opportunity to ask them any questions that you have about data mesh. By the way, if you don't know me, my name is Edelweiss Kammerman. I'm Oracle Ace Director. I'm part of the board member of the Analytics and Data Oracle User Community, and I'm leading the TechCast committee. Next slide, please. And we have a great news. We're going to have, again, our summit in presence in a location that we all love, which is the Oracle Conference Center in Redwood Shores, California. So save the date for the Analytics and Data Oracle User Community Summit for next year. It's going to be on March 14 to 16. And if you want to submit an abstract, you still have time. We extended the deadline for the submission, and you have until November 11. So do it now before you forget it. And we have merch. If you have, if you want to do some present or for yourself, or to some of your, techie friends, we have merch. You can see it in our NWC store at nwc.org. Okay. There is a lot of ways to communicate with us. We are a community that we really like to and in fact, we think that everything that we do is for the community, and we grow together as a community. We think that this is the best way to grow as professionals, just sharing the knowledge and sharing experience with each other. So we have a Slack channel, we have our website, of course, and all the sessions that we are sharing here, including this one, we're going to have it in our YouTube channel, so you can see it. And we are also going to share the slides. I think that's it. Before passing the control to Ziga, it is important for you to see that we have a chat and Q&A window. Please submit your question at any time on the Q&A window, and I'm going to ask those questions at the end of the session, so we can let Ziga to tell his story about OCI Vision and OEC. Ziga, if you don't know him, is a country manager of Qubix, and he's an Oracle Ace Pro, and I have to say he's a great speaker. His presentations are always very, very entertaining and very informative. So you're going to show this. Okay, so Ziga, the audience is all yours.
Thank you, Edel. So welcome to this presentation. So let's talk about some findings that my experience that I have encountered when I was playing with Oracle Cloud Infrastructure, the data lake services in particular, when I tried the vision and tried to combine the analytics. And here is a story that I have to share with you. But before we continue, let me just briefly say a few words about me. So Edel has already mentioned that I come from company called Qubix. We are quite active member of this community. We present quite regularly. I'm a country manager of Slovenian office. So one of the offices of Qubix is located in Central East Europe, Slovenia. And from my professional background, I come from the business analytics area, being 10 plus years as acting as a business analytics consultant. Funny enough, I spent 10 years also with Oracle before. I can say that I'm a board member of Slovenian Oracle user group for a number of years. And as Edel has mentioned, I'm Oracle Ace Pro for this particular area. The company that I'm coming from is Qubix. I don't want to spend too much words about it. The only thing that I can say is that we are very recognized vendor in the space of EPM and analytics, and we are growing into ERP area as well. The company is around 30 plus years, as you can see, and we have been engaged with on hundreds or thousands plus projects worldwide. As we operate beside Europe, where in the UK we have a headquarter office and Slovenian office, which is located in the continent, on the continent. We have offices in the United States, Australia, and also very fast growing office in India. And yeah, these are the main customers. We are particularly strong in financial services, retail, healthcare, and other industries, manufacturing, for example, as well. So that's really brief introduction to who am I, and to the company that I'm coming from. And let's take a look at the task that I'm trying to describe here. So the base idea of the exercise is that we have a library of chest X-ray images, and the idea is to build a model which we would use to help identify which patients have pneumonia and which patients haven't got, so they have normal healthy lungs. For this, the motivation for this exercise I got on the Kaggle, where you can find, if you go there, a number of these examples of this exercise, and here down below you have a dataset source listed. So if anyone wants to repeat the exercise, we might through time also publish this in the live labs, hopefully within next couple of weeks or months. So hopefully that will also work and live there. Okay, just sorry, somebody was trying to call me. So the first thought that we had, of course, since we were looking at Kaggle, was, okay, let's take some Jupyter environment and, you know, try to do that, this classification exercise in there. So in Oracle ecosystem, in Oracle Cloud Infrastructure, there is a data science cloud service, which basically is an implementation of Jupyter Notebook that supports Python coding with some additional flavor of Oracle. Some additional libraries are available to make it easier to connect to databases, to other infrastructure that is within Oracle Cloud Infrastructure. And there are some additional like automated machine learning libraries available, and so on and so forth. So what we've done is basically we created a script that actually did what we wanted. So we used a number of image libraries. We used TensorFlow, Keras library. We prepared the data. We enriched the data. So we produced the whole script, and at the end we use TensorFlow, Keras to predict the, to build the model, and then we analyzed the model and find out what was the performance of the model, and so on and so forth. So the final result in our, let's call it a manual coding exercise, was something like that. You know, we were achieving a result like in accuracy about 92%. Precision was also somewhere in that range. Recall, for example, much better, 97. So in general, we were quite satisfied with these results, knowing that we haven't spent much time in tuning and, you know, really working on this exercise. We were able to come quite close to the results that were publicly published on Kaggle with what we tried to achieve. So this is one way of solving the problem. Well, the problem with this example is that if we wanted to do this fast, we might run into some issues with data scientists, Python coders, and people like that, who are not always around when you need them. Okay. And personally, I don't count myself as a data scientist, just to be clear, right? Okay, so the other idea was then, okay, since we are Oracle, we are using Oracle Cloud Infrastructure, why don't we use some data lake services instead? So here is a high-level view of what we tried to do. So in our exercise now, we have used the following for services. The base service is cloud storage, where we store all the when we stored all images and, you know, when we access them and analyze them. So this is our primary databases. So everything was stored and uploaded to object storage. If you want to run a machine learning algorithm of any kind, and if this is a classification type of supervised learning, then you obviously need to know the cases when the case is, in our case, normal lungs or pneumonia infected lungs. So we need to have the target column, so to say. We use for this exercise the data labeling service in order to label those images. So each of the images, we created a data set with records, and each of those records was labeled by one of the two labels that we were trying to predict at the end. Then the third service is obviously Vision AI service, which was used to train the custom model for this image classification. What really impressed me is that, you know, you don't, once you have your data labeled, your images labeled, then basically there is no additional coding required whatsoever. So you just have to build a model, and then you can use it. And we use the model and we use the model, and we use the model for new cases, new images prediction or classification, and we used for that we used Oracle Analytics. So let me take you briefly what our exercise was about. So as I said, the first one is object storage. Everyone who is using Oracle Cloud Infrastructure probably came across with cloud storage. It's basically the storage where most of the user would put and store the unstructured data like images, and this is exactly what we have done. Yeah. How it looks like. So we use the upload utility that is part of this part of the buckets where we are storing our data, and the data look like this. So we organized the whole data set in two categories: the normal images for normal lungs and images for pneumonia lungs, which we will be used for training. Altogether, we are talking about 5,000 or something images, from which about 1,500 are stored in the normal folder, and we have about 3,000 and something that are in pneumonia folder. So the images that are showing pneumonia infected lungs. So basically that is our starting point. If you want to view what the image look like, you can go to the details of the object, and at the end you can present the image to you. So let me just show you how this looks in the environment. So this is object storage, and as any other object that is part of Oracle Cloud Infrastructure, we also have our images stored in some compartments, and in compartments we create buckets. So we have, as you can see, we have 3 buckets. The first one is the one that we use for training. Then there's another bucket where we uploaded the new cases, new images. And there's another bucket we need later when we start working with Oracle Analytics. We need to have a bucket for temporary storage of the results that are being produced when we are using machine learning algorithm from the Vision, and the temporary results are stored in that bucket. So if I navigate further down to train, as I said, we organize this into 2 folders. One is the normal. So we have 1,000 and so images of normal lungs. And if you want, we can take a look at images. So this is an example of the X-ray image that is there. So I have consulted some of my colleagues, from medical profession. I was told that these images seem to be quite good, and you can actually identify, even by looking at them, whether this is a normal lung or is a pneumonia affected lung. So for example, we have something like that, and we have this pneumonia affected, and you can see the image is rather different. With normal, you can see these nice shapes with boundaries, borders, and so on. Whereas in this one, you can see already without any machine learning that this could be something wrong with these lungs. Okay, so this is an example of object storage using. Why we organize this data in this way is simply because the data set that we downloaded from Kaggle actually has the same folder structure, so we didn't reinvent it anyhow. But you will see later in the next step, we actually use this situation to classify, to label based on the location where the image lies. Okay, so this was the first step. Then the second step is the data labeling service. So obviously, if we want to we need to do some machine learning on images. We just need to have something to label the image. As you can see, you will see in the demo, this is really intuitive service. But there's one minor problem at the moment, is that you have to do this labeling manually, and each one image per at a time. So you set a label for first image, then you skip to the go to the next one, and so on, so on. Luckily for us, because there are 5,000 images out there, Oracle in the documentation on data labeling actually provides you with the access to the GitHub, where you can find an example of Python or Java code for the labeling. So it was relatively easy for us just to take that code, make some minor changes, and we were able to run the labeling utility for all 5,000 images in a row. It takes about, I don't know, half an hour or so to go through everything, or maybe less. I don't know, I don't recall exactly, but basically it was really relatively easy to do that. Even for me, as I said, I'm not a Python developer, I'm not coder, to understand the code and make updates where we needed them to appear. Okay, so let me just show you how the data labeling works. So let me go beginning. So when you log in into data labeling, this is the home page, and you can see you can use this tool for image labeling, the text labeling, and document labeling. So it's not just about images, so it's really for unstructured data labeling, which you sometimes, or you just have to label the data in order to run some machine learning on top of it. So once we've done that, the first thing that you need to do is to create a data set. And the data set is based on the object storage. And this is the URL for the object storage that I'm using. So it's pointing to this particular object storage. And as you see, once you start importing, then records, so-called records, are generated. So each image gets a record. And once this is done, then we can start a labeling process, right? So the labeling process is relatively simple. You have an image, click on it, and the editor, label editor, I would call, opens, and you can actually simply just add a label, one of the two options, and that's it. You save it and go for the next. So what if we want to do the whole thing programmatically? So in this case, then let me switch back to my Python code. So we have put everything into this labeling folder, and we have a couple of files that are important. So the first file is where I define what are my config parameters. Eventually, the ones that I need to know is what is my region, what is the compartment ID, and what is the dataset ID that I'm going to use in this one. Then I provide the labels, and in this config, I also have something like a labeling algorithm that will be run when I do it. You can see you can use some regular expressions for that, but we'll come to that point as well. So then we have this first match algorithm. This is basically the only thing that we needed to change is this small statement where we are taking the name with whole path, and what we are interested in is just the folder name, which is the first part of the name. So we are taking that out and returning. So based on the name of the folder, we already know what is the label of the image, and this is the main program which basically runs through all the records in the record list and provides a label to an image. So what I have shown you, this is eventually the code that you get on GitHub from Oracle. So you don't need to invent much. There are just a couple of things that you really need to take pay attention to, but otherwise everything else is just as normal. You just use the code as it is. So once the data is labeled, then obviously we need to go and use the Vision service from the from all AI services. So, and we created a custom project, which in fact gave us quite good results, actually much better than we expected. As you can see from some metrics that are here, I tried a couple of times, and all models that I created fell into this 97% of precision of recall or F1 score, which is really, really good, in my opinion, for something that I actually didn't use any coding. It's just out of the box service that I can use and deploy. So okay, so let me just show you how that looks. So we have a Vision. So we have a Vision service. Let me just go. In this Vision service, you can do three things. You can use image for this service for image classification, and this is example of what we are doing. So you see an image and you classify that image to one of the classes, right? The other thing is object detection. There were a number of demos. I think one of the sessions a few weeks ago was also on object detection. So you try to detect the object within the image. And there is a document AI where you're working with documents. You extract all the content that is within the document and you try to classify that. What we did, we created a custom model, and you see there is already one custom model built, and each model, sorry, not a model, a project, each project can contain several models. You can see I have two here. There are two active, and for example, if I take this one, I can see the statistics. So this one is slightly less good than the one that I was showing on the slide. I can go and check the metrics for a little bit more in detail, and what these metrics tell me is that pneumonia is much better classified and predicted than the normal, which could be because of the number of images used in training for normal and pneumonia. There were about 3 times more images with pneumonia than normal, and this is probably the result of that. Okay, so but let me show you how you can use this out of the box. So let's take this pneumonia image here and bring it back to Vision, and let's upload this image from the bucket, from the object storage, and you can see the results are almost immediately. So we have the prediction, or we have label. So this algorithm thinks, this model thinks that pneumonia is almost 100% is presented in this image. There's slight possibility for normal lungs. But what is also important, and if somebody is developing application, everything is in JSON. So you can see this is the format of the JSON request. If you want to have the results back, this response will come again with JSON. So you can run this the request and response via REST API, and eventually you can build this in any application you're working with. And this is, I guess, I'm not that deep in Oracle Analytics development, but I guess this was also used in this example when we introduced Oracle Analytics. So when I use the fourth element of our exercise, there are a couple of things that I need to do. So when I start working with Oracle Analytics, I need to connect to the machine learning model to obtain the machine learning model and register that with Oracle Analytics. And the second thing is that I need to prepare the images somewhere on, and I have shown you those new cases on object storage, and bring those information also into Oracle Analytics. And then we merge the two things together in order to obtain the analysis. So what should I do in this exercise? The last remaining part of the exercise is exactly that. So I have to log into Oracle Analytics. So let me just, I hope many of you are familiar with Oracle Analytics. If not, I will provide you some links to get a little bit more about that. I could speak hours about Oracle Analytics, but we are now just to make this thing working. So the first thing that I need to do is I need to establish connection from Oracle Analytics to the Vision AI service. So this can be done like this. So I need to create a connection. And here is an option. So the connection type is OCI resource. And in this OCI resource connection, I need to provide the following information. So the connection name, then region identifier. So for example, for me, it would be Frankfurt, for example. Then Tennessee OCI identification identifier. So you can get that. Let me show you where that can be obtained. So for example, if I go to the tenancy, that tenancy ID, oops, yeah, it's here. So this is the OCID. This string needs to be copied, and this is then copied in here. The same is for OCI for user. And the last thing, you need to generate an API key, and this API key needs to be added to the list of the API keys with this user that I'm providing here. I'm not going to save it right now. Let me just show you how it looks like in my real case. So connection. So this is my, just like a box of chocolates Vision AID. So I can inspect it. So here is the information that I need to provide. Once I have it, I will instantly connect to the service. I must say that when I was doing it, there was no errors when I was setting the whole thing out. It was in the first attempt I was able to do all the necessary steps that I had to do. Okay. Then once the connection is set, let me just briefly, so I need to prepare images. So images, okay, I have gone from here. So I have images in object storage, new cases. And here I have just 10 images, just to be simple. So I have 6 or 7 normal, and some of some pneumonia affected images. So this is my new cases bucket, and I need to provide that information that I have these images in this bucket. And how do I do it? It's relatively easy. I can do it by providing bucket URL, and all images in the bucket will be taken into account. Or if I can list each and individual image in an Excel file, and that can be also imported. So I will have exactly the list of images that I would like to analyze. Let me just show you what is, I have used the bucket option. So, and you have to prepare an Excel file or whatever, but Excel file is, or CSV file is relatively easy, where you have these 3 elements. So you need to have some ID. It can be just random number, 1, 2, 3, 4, the bucket name, and the bucket URL. These are 3 information that you need to provide to Oracle Analytics, and Oracle Analytics will know where the images are located. So otherwise, if you have the images option, then you need to provide URL for each and every image in that CSV file. And this has to be uploaded as a data set. Okay. I'm going to use this data set later when I register my machine learning model with in the data set to produce the predicted data set. But before I do it, I have to register machine learning model from Vision AI now. So I go to this menu here on the top, and I can now select OCI register vision model, OCI vision models, and I will use the connection that I had. So these are the image models that I have, and this is the model that I need to register. I will not do that because I already have one, but I would need to provide the staging bucket here. So remember, this is the bucket that I mentioned just earlier, the one that will be for staging. So this is the bucket I need. Let me just copy it here. So, and now you can register your model. I will not do that because I have already registered this model in here, and you can find the model that you registered in the machine learning models list. So this is my machine learning model, and I can inspect it here. This is, and you can have also the details, the output columns that are coming from, that are returned, and that's it. So I have my model registered. Very similar, as you're familiar how to register the OML model from Autonomous Data Warehouse, for example. The same process is here. So once I have this, then the next step would be preparing the predicted database dataset based on the model and the new cases from the bucket. And I can do this using the data flow. So I have already prepared this data flow. I will not go and build it from scratch, but basically this is the flow that I need to provide. In general, there would be only 3 steps: the data set, the apply AI model step, and save data. Because I wanted to do some additional visualization, I just added two additional columns to the result set. But you can see I'm using these new cases from box data set. Then here is the apply AI model, which is now new in the latest OAC. I add this model, and these are the parameters of the model. So we have some output columns, and there are some parameters that I need to provide. The one that I need to set is this bucket URL. This is the URL of the bucket, and that's basically the only thing I need to do in this step. I provide the URL, so the model will know where to find the images. Then I just added. I have taken the image name from the whole URL, and I'm just setting the actual case, so I can then compare actuals against predicted, and then I save it. And you can already see, some of the things are already happening in there. Now it's running. The end result will be a new data set will be created with these particular attributes, and I can use this in my visualization. So you can see we have object name, which is the prediction, and the confidence. For each image, we have 2 rows, one for first and the second label. We have the confidence, and then we can compare this against the real actual case. Okay, so the last step that is required is to do the visualization. But just before that, let me just show you one thing that you still need to define. The first thing that you need to define is the save domains. If you don't do that, you will not see images. So the last row is actually the domain that is in my region, EU Frankfurt, oraclecloud.com. And I need to indicate that I'm going to download from there, from the bucket that is in that domain. I'm going to have images, and I would like to also connect. So these are the 2 things that I need to define here under the save domains. If you don't do that, you will not see an image. Okay. And the second thing is I added one extension, which is this Vision series. This is an extension that actually enables you to visualize images in object storage. Yeah. So, and this can be obtained from Oracle Analytics sample library. I apologize, I haven't prepared myself in advance. And you will find this under the developer link here. Extensions, or you can already download from here. So this is download. This is the place where you download. Okay, it's still loading. So the plugin, you have to download this plugin. Okay, and once you install it as an extension in the extension library, you can then proceed to the visualization. And since I'm almost running out of my time, so let me just finish. So this is an example of the visualization. So the color here means the actual class, and we can see the percentages of confidence for normal and pneumonia label. And if I use this nice use as filter option, you know, we can browse through all the images and inspect them. Okay. If I return to the edit mode, maybe this visualization, additional visualization, let me just show you where you can find this Vision AI plugin. So it is here, and it looks like this. So what you need to provide in the image location, you need to provide the image location, and this is everything you need to do. If we had, you know, object recognition, you would need to provide the vertices as well, which will be the object recognized within the image, but we are not using that example right now. So this is really, really, really in fast forward mode, how you can easily obtain visual images, and you can actually set up a machine learning model and visualize that through Oracle Analytics Cloud. I hope you will find this presentation useful. I have at the end of the presentation, I'm providing some of the useful links. To be honest, I was really surprised of the quality of the documentation available for all four services. Of course, I'm quite familiar with analytics, so I was not looking into that too much. But with the data labeling and vision, it's really, really nicely presented. And if somebody wants to have a little bit more details on what I've shown in this demo, I have already published free blog post on this content, and you can also look at it if you want. So that's from my side. If there are any questions, I would be glad to answer.
Yeah, thank you so well. That presentation was great, Ziga. So we have a couple of questions.
Mm-hmm.
Well, one is an appreciation from Philippe Lyon. Thanks a lot, Ziga, for the detailed webcast on the OCI Vision integration, very detailed and valuable. So coming from him is a great compliment.
Yeah,
so, and we have one question from Steve Rutland, who says, so for the user, where the user that you use to connect OCI Vision from OEC, is the user used to connect to the Vision AI from OEC via generic service account rather than the OEC users account, in order to allow all users to access machine learning models without all users having access to Vision AI?
So, okay, this demo, I've been using my own user account, right? I haven't shown you a couple of things. First of all, the users and groups, and there are some policies that you need to define. And eventually you will see, if you go through the documentation, it's really nicely documented what policies you need to have access to specific objects, from object storage or machine learning models, but connection from Oracle Analytics to machine learning model is actually using my own credentials. So let me show you. For example, if you go to the user settings, so you remember I was providing the connection from analytics to ML. This is my OCID, so I use this one. And then in the API keys, I also had to, I think this was one of these keys that was generated in the connection in Oracle Analytics. I had to put it here. So that makes this connection, and basically I'm connecting to the machine learning as myself. So anyone who would be using this would be using this user. I hope
Philippe is also adding that all Oracle Analytics Cloud users can leverage the model. So the model will connect to OCI only using that user, as for example, in your case, your credentials, listen to the connection, but so only one user is needed. So the user that can connect,
has access.
Exactly, can connect to the OCI Vision model, but every other user can use it.
I will also provide a second deck of slides to Edel after the presentation where I have screenshots, so you might be able to see the details of that as well.
Perfect. So, and for the people that is asking if we can rewatch this video, of course, we are going to, we have a YouTube channel, as I said at the beginning. So this video is going to be published there, so you can see it many times as you wish. We also share it in our website, nwc.org, and also sharing the slides with the information also from the speaker. So you're going to have all the material, you're going to have all the links, and in addition to this, if you want to as I mentioned to you, we have our Slack channel. You can join our Slack channel, and then we are sharing a lot of more stuff about this and about all sessions that we have shared. You can ask questions, so it's going to be good for you if you start connecting with us. Okay, any more questions, guys? Okay, it seems like we don't have more questions. Ziga, thank you so much. It was a great session. We're going to have, I imagine, a lot of reviews in our YouTube channel for this session too. So thank you everybody to attend our TechCast. Please keep in mind that we continue having a lot of TechCasts until the end of this year. We're going to have probably a couple of weeks out for the Christmas and holiday season, but we are going to come back to more technical content. And the next one is on November 17th, and it's going to be a data mesh panel. Okay, so remember, you can ask all the questions that you want from for our experts, and we're going also to introduce what is data mesh and what is this about. Okay, thank you so much, everybody, for your time, and have a great day. Thank you.
Thank you, Edel. Bye.
Bye-bye.